Recorded is rolling. Today is Friday, October 14th, and I have a story for you guys called The Fermi Paradox. Of course, next class period is pep rally, so this is a good fit today. Right now, before I start reading the story, this is actually a very famous essay that was published in 2014 by the author is Tim Urban. So I'm going to read this to you guys. But let me give you guys a little bit of context. So Fermi, who is this guy? You guys are familiar with the Manhattan Project?
Yes.
Yeah, so when the United States built atomic weapons back in the 1940s, he was one of the scientists that was working on that project. And one thing that he liked to do, one of his thought processes was he would come up with just crazy questions and say, how could I somehow mathematically hone in on some kind of a good idea of an answer? For example, when they were blasting off these nuclear weapons, what he did is he stood within sight of the nuclear blast. He would take small pieces of paper, and then when the blast wave was across them, he would drop the piece of paper, watch how they fluttered. It's like, well, if I know the mass of the paper and the density of air and how far away from the shock wave, blah, 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 it puts all these variables together. He was able to estimate the blast, the size of the blast, like how many tons of TNT equivalent. Okay? And he actually got it really close just from that estimate. That's just one example. But he turned his another example, and that's going to lead straight into this story, is he asked the question, how much intelligent life should there be expected to be out there in the galaxy, or maybe the universe, if you want to get a little bit wider? Now, this essay that I'm going to read, it sort of references, without mentioning it, something called the Drake equation. So let me take you guys through that. Now, the Drake equation tries to answer this question using pretty much this Fermi type method, where if you start off with just a hard count of how many stars are out there, right? Which is a number we can get a pretty good idea on, a pretty good window, how many stars are out there. And then you start multiplying this number by certain ratios, like what proportion of the stars could be similar to the sun enough that they could support life, right? How many of them are orbited by planets? How many of those planets have Earth-like conditions, maybe liquid water? Okay? What's the chance of life developing? What's the chance of developed life becoming intelligent and developing technology? Right. Anyway, you multiply all these proportions together, and at the end, you get a number. And it turns out that this number is so crazy that, well, that's where this word paradox is about to come in. All right, with all that context, here we go. Right, so, The Fermi Paradox by Tim Urban. Everyone feels something when they're in a really good starry place on a really good starry night, and they look up and they see this. Raw. How many of you guys have ever been out in the deep country where there's no light pollution and seen this at night? Yeah, a couple of guys, some of you guys, right? If you guys ever get a chance, Midwest, out west, national parks, yeah, do it. Because when you guys see the night sky, like here in like suburbia, you guys know we're surrounded by light pollution, which has really only existed for about the last 100 years or so, right? Since electric lighting's been around. But for thousands of years, that's what people saw, right? And so back to the essay. Some people stick with the traditional feeling struck by epic beauty or blown away by the insane scale of the universe. Personally, I go for the old existential meltdown followed by acting weird for the next half hour. But everyone feels something. Physicist Enrico Fermi felt something too. He asked the question, where is everybody? See, a really starry sky seems vast, but all you're really looking at is your very local neighborhood. On the very best nights, we can see up to about 2,500 stars, roughly 100 millionth of the stars in our galaxy. And almost all of them are less than 1,000 light years away from us, less than 1% of the diameter of the Milky Way. So what you're really looking at is this. Now, of course, we don't really have a picture of our Milky Way galaxy from this point of view, but if we did, this served as a model, right? Then all the stars you can see, all the constellations, Orion, Big Dipper, blah, blah, they're all pretty much inside that red circle. That's pretty much as far as you can see. Okay. So when confronted with the topic of stars and galaxies, a question that tantalizes most humans is there other intelligent life out there? So let's put some numbers to it. So here's where the next few paragraphs basically covers a version of the Drake equation. As many stars are in our galaxy, somewhere between 100 and 400 billion, there are roughly an equal number of galaxies in the observable universe. So for every star in the colossal Milky Way galaxy, there's a whole other galaxy out there just in the observable universe. If it helps for context, I have a poster with 1,000,000 dots on it. And got a picture of the galaxy. I got Hubble's ultra deep field right there. That's the edge of the observable universe. There to us. The science world is not in total agreement about. Wait, pause this. Right, pause. Resume recording. Yeah, as many stars as there are in our galaxy, somewhere between 100 and 400 billion, there is an equal number of stars in the observable universe. So for every star in the Milky Way, there's a whole other galaxy out there. Altogether, that comes out to a typically quoted range of between 10 to the power 22 and 10 to the power 24 total stars. So for every grain of sand on Earth, there are 10,000 stars out there. The science world is not in total agreement about what percentage of those stars are sun-like, similar in size, temperature, luminosity. Opinions range somewhere between 5 and 20%. Let's go with the more conservative estimate, about 5%, the lower end of the number of total stars. So we're taking two lower boundary estimates. We're going to multiply this together, and that gives us 500 quintillion, also called 500 billion sun-like stars. Right? Remember that poster with a million dots on it? 1,000 of those posters is a billion. And if you did a billion times 500, okay, so we're talking about crazy big numbers. There's also a debate over what percentage of those sun-like stars might be orbited by an Earth-like planet. One with similar temperature conditions, it might have liquid water, potentially support life similar to Earth. Some say as high as 50%, but let's go with the more conservative 22% that came out of a recent study. That suggests that there's a potentially habitable Earth-like planet orbiting about 1% of the stars in the total universe, a total of 100 billion Earth-like planets. So there are 100 Earth-like planets for every grain of sand in the world. Think about that next time you're on the beach. Moving forward, we have no choice but to get completely speculative. Let's imagine that after billions of years of existence, 1% of Earth-like planets develop life. This is a completely speculative number, but just throw a number at it, 1%. If that's true, then every grain of sand would represent a planet with life on it. And let's imagine that of 1% of those planets, the life advances to an intelligent level like it did here on Earth, where we have reading, writing, mathematics, technology. That would mean that there were 10 quadrillion or 10 million billion intelligent civilizations in the observable universe. Now, to be fair, observable universe, maybe that's a little bit too big. So, next paragraph. Let's just move back to our galaxy, just the Milky Way. And run the similar type math, same proportions, da 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 da. All right. What was that total up to? We would, so 100 billion stars, lower estimate for stars in the Milky Way. We would estimate that there are 1 billion Earth-like planets and 100,000 intelligent civilizations just in our galaxy, right? Just with conservative type numbers. All right, SETI, this is an acronym, stands for Search for Extraterrestrial Intelligence, is an organization dedicated to listening for signals from other intelligent life. If we're right that there are 100,000 of these intelligent civilizations just in our galaxy, and even a fraction of those are sending out radio waves or laser beams or other modes attempting to contact others, then shouldn't SETI's satellite array pick up all kinds of signals? But it hasn't, not one ever. So where is everybody? It gets stranger. Our sun is relatively young in the lifespan of the universe. There are far older stars with far older Earth-like planets, which should in theory mean civilizations far more advanced than our own. As an example, let's compare our 4.5 billion year old Earth with a hypothetical 8 billion year old planet X. Right, so let me leave the essay just for a moment, give you guys some background context here. Right, so the age of the universe is pretty well determined to be about 14 billion years old. It has to do with like redshift of other galaxies, extrapolate backwards in time, 14 billion years, this whole timeline, 14 billion years. Our solar system, including our own planet Earth, is about 4.5 billion years old. That's pretty well established if you compare a ratio of like lead to uranium and rocks. Every solar system has a unique fingerprint, sometimes it's called, ratio of certain elements. So you can say pretty well what's been established is that there was some huge nova event that happened about 4.5 billion years ago and created all the elements and everything in our solar system. Okay. So 4.5 billion years is the story of our planet, but the whole universe, 14 billion years, that leaves billions of years of extra opportunity for other planets to develop. So it's not just that there's a huge quantity of other stars and planets out there. There's also this whole dimension that's oftentimes overlooked, which is just the time dimension. Just there's a crazy amount of time that's existed without the Earth even being part of the story. All right, so back to the essay. If Planet X has a similar story to Earth, let's look at where their civilization would be today. Oh, the technology and knowledge of a civilization only 1,000 years ahead of us could be as shocking to us as our world would be to a medieval person, right? So you jump in a time machine, go back 1,000 years ago to the medieval ages. Let me pause this. Pause, resume recording. All right, so we're talking about how technology developed. You guys know technology developed sometimes called like exponentially, Moore's law, the whole deal. So if you jump in a time machine, went back to medieval ages, pull out your cell phone and start playing Candy Crush, probably next thing that happens is you end up burning up the stake. Okay? But so a civilization 1,000,000 years ahead of us might be as incomprehensible to us as human culture is to chimpanzees. And this hypothetical purple planet X is 3.5 billion years ahead of us. Right. Here's another contextual number. You guys know the dinosaurs died out about 65 million years ago, right? That's even small compared to the numbers we're talking about. There's something called the Kardashev scale, which helps us group intelligent civilizations into 3 broad categories according to the amount of energy that they use. A type 1 civilization has the ability to use all the energy of their planet. We're not quite a type 1 yet, but we're close. Carl Sagan created a formula that puts us at about type 0.7. A type 2 civilization can harness all the energy of their host star. Our feeble type 1 brains can hardly imagine how someone would do this, but we've tried our best imagining things like this Dyson sphere. So now a Dyson sphere, it might be a physical shell, it might be like billions of independent satellites, but somehow you're capturing either most or all of the energy from a star, right? And then you can use that energy to do cool stuff with that, right? That's like a type 2. A type 3 civilization blows the other 2 away, accessing power comparable to that of the entire galaxy. If this level of advancement sounds hard to believe, remember that purple planet X and their 3.5 billion years further development. If a civilization on that planet were similar to ours, been able to survive all the way to type 3 level, the natural thought is that they probably have mastered interstellar travel by now, probably even colonizing the entire galaxy. How would they do that? Well, what you could do is you could, here's your home base right here. You could send out a couple of teams to new planets, spend 500 years or so self-replicating using the raw materials on their new planet, terraforming, the whole deal, and then rinse and repeat this process. Right? Now, that might seem slow, right? Like, I mean, 500 years ago, Columbus had just barely made his way to North America, right? So we're talking about 500 years between iterations here. I mean, okay, that sounds like a long time, right? But remember, power of exponents. This is like this is logarithmic math we're running into. What that means is that even without traveling anywhere near the speed of light, this process could colonize the whole galaxy in, according to this essay, 3.75 million years. Maybe I'll round that to 4 million years. 4 million years? That's a relative blink of an eye when talking about the scale of billions of years. Again, dinosaurs, 65 million years ago. 4 million years is all it would take to do this whole process for an entire galaxy. Continuing to speculate, if 1% of intelligent life survived long enough to become a potentially galaxy colonizing type 3 civilization, these calculations suggest that there should be at least 1,000 of these type 3 civilizations just in the Milky Way galaxy alone. And given the power of such a civilization, their presence would likely be pretty noticeable. And yet we see nothing, hear nothing, visited by no one. So where is everybody? Welcome to the Fermi paradox. We have no answer to the Fermi paradox. The best we can do is possible explanations. If you ask 10 different scientists what their hunch is about the correct one, you'll get 10 different answers. You know, when you hear about humans of the past debating about whether the Earth was round or sun revolved around the Earth, or thinking that lightning happened because of Zeus, and that all seems so primitive and in the dark, that's about where we are with this topic. And taking a look at some of the most discussed possible explanations of the Fermi paradox, let's divide them into 2 broad categories. Those explanations that assume that there is no sign of type 2 and 3 civs because there are none of them out there, you know, for a list of reasons we're about to go into. And later on, those group of explanations that assume that they are out there, but we're not seeing or hearing from them for other reasons. So back at big picture, the structure of this essay is basically in 3 parts. I just finished part 1, which is the setup. Right. Part 2 is a group of explanations that says there probably is no other intelligent life. And then the third part of this essay is, well, there probably is intelligent life and we're not seeing it for some reason. Okay. Now, for context, this essay was published in 2014. That was a few years before our government officially said that, yeah, UFOs do exist and that's not our technology. Now, we still don't know what these unidentified flying objects are. We just know it's not human technology, right? But that could definitely put an interesting spin on this whole essay, right? Right, so explanation group 1, there are no signs of higher civs because none of them exist. Those who subscribe to group one explanations point to something called the non-exclusivity problem, which rebuffs any theory that says there are higher civilizations, but none of them have made any contact with us because they all fill in the blank. Group one people look at the math, which says that there should be so many thousands of higher civilizations that at least one of them would be an exception to whatever fill in the blank rule. So even if a theory held for 99% of higher civilizations, the other 1% would behave differently and we would become aware of their existence. Therefore, say group one explanations, it must be that there are no super advanced civilizations. And since the math suggests that there are thousands of them just in the Milky Way, something else must be going on. That something else is called the Great Filter. The Great Filter theory says that at some point from pre-life to type 3 intelligence, there is a wall that all or nearly all attempts at life hit. There's some stage in the long evolutionary process that is extremely unlikely or impossible to get beyond. This is the Great Filter. If this theory is true, the big question is, where in that timeline does this Great Filter occur? Because it turns out when it comes to the fate of humankind, this question is very important. Depending on where that Great Filter occurs, we're left with three possibilities. We're rare, we're first, or we are headed for inevitable disaster. All right, so let's get a bit more granular. Possibility one within this giant umbrella of ideas. We are rare. To say the Great Filter is behind us, one hope we have is that the Great Filter is behind us. We've managed to surpass it, which would mean that it's extremely rare to make it to our level of civilization. That diagram you're looking at shows only 2 species making it past, and we're one of them. This scenario would explain why there are no type 3 civilizations, but it would also mean that we could be one of the few exceptions now that we've made it this far. It would mean that we have hope. On the surface, it might sound a bit like people 500 years ago suggesting that the Earth is the center of the universe. It implies that we're special. However, something that scientists call the observation selection effect suggests that anyone who is pondering their own rarity is inherently part of an intelligent life success story. And whether they are actually rare or quite common, the thoughts that they will ponder and conclusions they draw will be identical. This forces us to admit that being special is at least a possibility. And if we are special, when exactly did we become special? Which step did we surpass that almost everyone else gets stuck on? One possibility, maybe the Great Filter could be at the very beginning. It might be incredibly unusual for life to begin at all. This has to be a candidate because it took about 1 billion years of Earth's existence for life to finally start up. And we've tried extensively to replicate this event in labs, and we've never been able to do it. We've never been able to create life from scratch with just chemistry. If this is indeed the Great Filter, it would mean that not only is there no intelligent life out there, there may be no other life at all. Another possibility, maybe the Great Filter could be the jump from simple prokaryote cell to complex eukaryote cell. After prokaryotes came into being, basically very simple bacteria, they remained that way for almost 2 billion years. So like half of Earth's history was basically just simple bacteria before making the evolutionary jump to being complex and having a nucleus. Let me add to that a little bit. You guys probably learned in biology that you have 2 sets of DNA. You guys know about that? Right, so you have your mitochondrial DNA and then your main DNA. Right? So your regular DNA says like, oh, you have 10 fingers and 2 eyeballs, blah, blah, blah. Right? But there's also this mitochondrial DNA, which lets you like process oxygen and create energy and blah, blah, right? Okay. And these two work symbiotically. Now, the main idea is that a couple of billion years ago, there were probably 2 separate bacteria that combined. And instead of one digesting the other, like eating it and consuming it, they worked symbiotically and created like the first eukaryotic cell. So the first like double set of DNA. Right. And then all animals, all plants, all mushrooms, all have this eukaryotic double DNA structure. Okay. So if this is the Great Filter, it would mean that the universe is teeming with simple prokaryote cells and almost nothing beyond that. So maybe the universe is basically filled with simple bacteria. There are a number of other possibilities. Some even think that the most recent leap we've made to our current intelligence and technology is a Great Filter candidate. While the leap from semi-intelligent life, think chimps, to intelligent life, think humans, might not first seem a miraculous step, Steven Pinker rejects the idea of an inevitable climb upward of evolution, since evolution does not strive for a goal but just happens. Right? This is Darwinian natural selection. It uses the adaptation of its most useful for a given ecological niche, and the fact that on Earth this has only led to technological intelligence only once so far may suggest that this outcome of natural selection is rare and hence by no means a certain development in the evolution of a tree of life. Right? Now, there are other animals that, okay, let me pause this again. Okay, pause, resume. Right, so there are other animals that are like very intelligent. Like for example, an octopus is, but an octopus doesn't have any like fingers and thumbs to like write down or like put together technology. Or what about like there are some other animals that actually do use like some basic technology. So yeah, maybe not. Okay, let me skip a little bit here. So, here's an interesting point. If scientists find some here. If we are indeed rare, it could be because of a fluky biological event, but could also be attributed to what's called the rare Earth hypothesis, which suggests that although there may be many Earth-like planets, maybe the particular conditions of Earth, maybe something related to the specifics of our solar system, maybe our relationship with our moon, which is unusually large for a planet our size and helps stabilize our axis, maybe certain weather oceanic conditions, maybe something about the planet itself is exceptionally friendly to life that we just kind of take for granted or overlooking or not understanding how important it is. Next part, 2, maybe we're first. For group 1 thinkers, if the great filter is not behind us, one hope that we have is that the conditions in the universe are just recently, for the first time since the Big Bang, reaching a place that would allow intelligent life to develop. In that case, we and many other species may be on the way to superintelligence, but it just hasn't happened yet. Talking about like Dyson spheres and blah, blah, blah. We happen to be here at the right place at the right time to become one of the first superintelligent civilizations. One example of a phenomenon that could make this realistic is the prevalence of gamma ray bursts, insanely huge explosions that we've observed in distant galaxies. In the same way that it took Earth a few 100 million years before all the asteroids and volcanoes died down for life to even become possible, it might be that the first chunk of the universe's existence was full of cataclysmic events like gamma ray bursts that would incinerate everything from nearby from time to time and prevent life from developing past a certain stage. Now, perhaps we might be in the midst of an astrobiological phase transition, and this is the first time that life has been able to evolve this long uninterrupted. Possibility 3, that we are headed for inevitable disaster. Maybe this great filter is ahead of us. If we are neither rare nor early, group 1 thinkers conclude that the great filter must be in our future. This would suggest that life actually does regularly evolve to where we are, but that something is preventing life from getting much further and reaching high intelligence in almost all cases, in which case we would be unlikely to be an exception. One possible future great filter is a regularly occurring cataclysmic natural event, like the aforementioned gamma ray burst. Right? I mean, there could be a gamma ray burst headed our way right now that we just wouldn't know because it's traveling at the speed of light, and then tomorrow, like happy birthday, the atmosphere is blown off. So sweet dreams. Except that they're unfortunately not done yet. It's just a matter of time before all life on Earth is suddenly wiped out by one. Another candidate is the possible inevitability that all intelligent civilizations end up destroying themselves once a certain level of technology is reached. A really commonly cited example, of course, is nuclear weapons. We could end all life tomorrow if we wanted to.
Hydrogen.
Yeah.
At the end of the day, you're just smashing atoms together as long as you can do that.
Right.
It's literally the same thing cavemen did with rocks, just on a small scale. So it's easy to do, and well, it's incredibly dangerous. So.
Yeah, exactly, right. Yeah, or could it even be like something more subtle, like genetic engineering? If you like genetically engineer like a virus or bacteria that just like wipes everybody out. Yeah, so who knows? Could be a lot of things, right? This is why Oxford University philosopher Nick Bostrom says that, quote, "No news is good news. The discovery of even simple life on Mars would be devastating because it would cut out a number of potential great filters behind us. And if we were to find fossilized complex life on Mars," Bostrom says it would, quote, "it would be by far the worst news ever printed on a newspaper cover because it would mean that the great filter is almost definitely ahead of us, ultimately dooming the species." Bostrom believes that when it comes to the Fermi paradox, the silence of the night sky is golden. All right, so there's the second section of this essay. Now let's go to the final section, which is explanation group 2, which says that maybe type 2 and 3 intelligent civilizations are out there, but there might be logical reasons why we have not heard from them. Okay, so last bit. What are we doing here? 3, 4. All right, so we got 9 minutes. Group 2 explanations get rid of any notion that we're rare or special or the first at anything. On the contrary, they believe in what's called the mediocrity principle, whose starting point is that there is nothing unusual, or rare about our galaxy, our solar system, our planet, our technology, or civilization, until evidence proves otherwise. They're also much less quick to assume that the lack of evidence of higher intelligence beings is evidence of their non-existence, emphasizing the fact that, again, our search for ET only, there you go. It's basically within that red circle. Right. So they have a number of possible explanations. Here are 10. Possibility 1. Super intelligent life could very well have already visited Earth, but just before we were here. In the big scheme of things, sentient humans have only been around for some thousands of years. You guys know recorded history only goes back, what, about 5,000 years or so? So if there was alien contact like 10 or 15 or 20,000 years ago, just nobody could have ever recorded that because writing had not been invented by that point, as far as we know. Possibility 2. The galaxy has been colonized, but we just live in some desolate rural area of the galaxy. For example, maybe the Americas have been colonized by Europeans long before some small Inuit tribe in far northern Canada realized that this had happened. There could be an urbanization component to the interstellar dwelling of higher species, in which all neighboring solar systems in a certain area are colonized and in communication, and it would be impractical and purposeless for anyone to deal with coming all the way out to some random part of the spiral where we happen to live. Possibility 3. The entire concept of physical colonization could be a hilariously backward concept to a more advanced species. Like, remember that Dyson sphere for the Type 2 sieve? With all that energy, maybe they will have created a perfect environment for themselves that satisfies their every need. Maybe they will have solved the question of economics, which is scarcity. Maybe they have crazy advanced ways of reducing their need for resources and zero interest in leaving their happy utopia to explore a cold, empty, undeveloped universe. An even more advanced civilization might view the entire physical world as a horribly primitive place, having long ago conquered their own biology and uploaded their brains to a virtual reality, eternal life paradise. Living in the physical world of biology, mortality, wants, and needs might seem primitive to them the way we view primitive ocean species living in a frigid, dark sea. Possibility 4. Maybe there are scary predator civilizations out there, and most intelligent life knows better than to broadcast any outgoing signals and advertise their location. This is an unpleasant concept and would help explain the lack of any signals received by SETI satellites. It also means that we might be the super naive newbies who are being unbelievably stupid and risky by ever broadcasting outward signals. There's a debate going on currently about whether we should engage in METI, which stands for Messaging to Extraterrestrial Intelligence, the reverse of SETI, or not. And most people say that we should not. Stephen Hawking warns, if aliens visit us, the outcome would be much as when Columbus landed in America, which did not turn out well for the Native Americans. Even Carl Sagan, a general believer that any civilization advanced enough for interstellar travel would be altruistic and not hostile, called the practice of METI deeply unwise and immature, and recommended that, quote, the newest children in a strange and uncertain cosmos should listen quietly for a long time, patiently learning about the universe and comparing notes before shouting into an unknown jungle that we do not understand. Possibility 5. There's only one instance of a higher intelligent life, a super predator civilization who is far more advanced than everyone else and actively keeps it that way by exterminating intelligent civilization once it gets past a certain level. The way it would work is that it would be an inefficient use of resources to go around exterminating all emerging intelligences, maybe because most just die out on their own. But past a certain point, the super beings make their move because to them, an emerging intelligent species becomes like a virus that starts to grow and spread, and maybe actually compete for resources they actually really do care about. This theory suggests that whoever was the first in the galaxy to reach intelligence won, and now no one else has a chance. It would explain the lack of activity out there because it would keep the number of super intelligent civilizations to just one. Possibility 6. Maybe there is plenty of activity and noise out there, but our technology is just too primitive, or we're listening for the wrong things. Oh, God. Okay. All right. So, like for example, walking into a modern day office building, turning on a walkie-talkie, and then not hearing anyone and concluding, oh, well, no one must be here and it must be empty. But of course you wouldn't hear anyone because everyone's using cell phones and texting. Or what if some other civ communicates exponentially faster or slower? So if it takes them 12 years to say hello, that if we get that signal, all we would interpret that as is just white noise. Possibility 7, we are receiving contact from other intelligent life, but the government is hiding it. So the author of this essay says that he doesn't personally subscribe to this theory, paraphrasing that, although this was, of course, released before 2014, so a little dated, but that's all right. Possibility 8, higher civilizations are aware of us and are observing us, also known as the zoo hypothesis. As far as we know, superintelligent civilizations exist in a tightly regulated galaxy, and Earth is part of a vast and protected national park with a strict look but don't touch rule for planets like ours. We wouldn't notice them because if they wanted to watch us, observe us, they would know how to do so without us realizing it. Maybe there's a similar rule to Star Trek's Prime Directive, which prohibits superintelligence beings from making open contact with civs like ours until maybe we reach some level. Possibility 9, maybe they're here all around us, but we're too primitive to perceive them. There's this analogy of building a 10-lane superhighway next to an anthill, with the ants be able to understand what that technology even is. Right. Possibility 10, maybe we're just completely wrong about reality altogether. There are a lot of ways we could be totally off about the way we think. The universe might appear one way and actually be something else entirely, like a hologram, or maybe there are extra dimensions that we can't sense or measure or have access to. String theory suggests there should be about 10 or 11 dimensions, but we can access 3 spatial dimensions in time. Right? Or maybe we're the aliens and we're planted here as part of an experiment, some form of fertilizer. There's even a chance that we're all part of a computer simulation, and by some researcher from another world, and other life forms simply weren't programmed into the simulation. As we continue along our possibly futile search for extraterrestrial intelligence, I'm not really sure what I'm rooting for. So this is a concluding paragraph here. Frankly, learning that we are either officially alone in the universe or officially joined by others would be creepy, which is a theme with all of the surreal storylines above. Whatever the truth actually is, it's mind-blowing. Beyond its shocking science fiction component, the Fermi paradox also leaves me with a deep humbling, not just the normal, oh yeah, I'm microscopic and my existence lasts for 3 seconds humbling that the universe always triggers. The Fermi paradox brings out a sharper, more personal humbling, one that can only happen after spending hours of research hearing your species' most renowned scientists present insane theories, change their minds again and again, wildly contradict each other, reminding us that future generations will look at us the same way we see ancient people who were sure that the stars were on the underside of a dome in the sky and think, wow, they really had no idea what was going on. Compounding all of this is the blow to our species' self-esteem that comes with the talk of type 2 and 3 civs. Here on Earth, we're the king of our own little castle, proud ruler of this planet. And we're in this bubble with no competition and no one to judge us. We're never confronted with the concept of being dramatically technologically inferior to anyone else. But after spending a lot of time with these possible type 2 and 3 civs, maybe that recontextualizes our place. That said, given that my normal outlook is that humanity is a lonely orphan on a tiny rock in the middle of a desolate universe, the humbling fact that we're probably not as smart as we think we are, and the possibility that a lot of what we're sure about might be wrong, sounds wonderful. It opens the door just a crack that maybe, just maybe, there might be more to the story than we realize. Just in time. Right, so let me get lights. You guys ready for lights? Right. Lights. Right, and then you guys enjoy the pep rally. Have a great weekend. And on Monday, we're going to continue the story of gravitation and orbits.